Okay, next session, I would like to talk about the evolution of our PUF-based security subsystems. I think everybody knows that we have become the world leader in the OTP, IP, and recently we invent PUF technology from the OTP. And then we add a lot of digital design and also integrate our OTP and the PUF together to become the root of trust. So this section I will talk about that to explain that how we did it from the OTP to the PUF-based security subsystems. And you can turn to page 13 to see the figures. Okay. So based on our OTP technology, we developed a PUF-based chip fingerprint IP. Both OTP and the PUF, which stand for the physically uncomparable functions, are important IP for a security subsystem. Within a security system, the most important component is the root of trust, which including key storage and the key generation functions. So by integrating OTP with PUF, we can create new IP solutions that include hard IP, such as our PUF-RT, and that is our root of trust IP. And our security subsystem SOC IP was created by integrating a crypto engine, which is a sub IP, with the root of trust IP, which is our hard IP. So we create the hard IP by integrating OTP with PUF, resulting in PUF-RT, which is the root of trust IP. And furthermore, we created a purely digital crypto engine from different cryptographic algorithms and the digital circuit IPs to perform the cryptographic computation of encrypting and decrypting data for security operations. And to facilitate the security operations in SOC, we must protect data at the rest and data in transit by using the operation of the security subsystem. We also developed firmware and the software and the various tools to perform security functions in the security subsystem IPs, such as signing of the software and the over-the-air updates and the security boot, etc. With the growing demands for security in different applications, we are seeing growth from our security products in current business opportunities. Therefore, we expect to dominate the security IP market with our ready-to-go root of trust technology. Our security IP have a comparative advantage because they are all proven in many different processes, just like our OTP technology, and also developed in over 600 process platforms over the past 22 years. So we create the new business opportunities by expanding our technologies from OTP to PUF-based root of trust and the security subsystem, and also the security function software, which will propelling us beyond selling individual IP to selling security subsystem SOC IPs and related security software services. So as eMemory is an established IP company, there are different platforms that we can use to leverage our sales in security IPs and the subsystems. Include foundry platforms. In the past, foundry platforms were our main champions for our OTP technologies. Now, we license our security technologies to major foundries, such as TSMC, Intel, UMC, and the global foundries, and are also jointly promoting with them to further the business effort. And the second platform is CPU partners. We recently announced our cooperation with CPU partners such as ARM and RISC-V by providing a security subsystem to integrate with the CPU IPs in many applications. SoC customers require CPU and the security subsystem IPs. And the third platform will be on the OEM and the design services. Many OEM companies have started to ask design services companies to customize their chips in system devices. Most of these system devices require strong security functions, which our security IP can provide. And in addition to the above platforms, I would like to also address the future technology, which is so-called the future of computing architecture. It's moving toward confidential computing. Confidential computing architecture protects the program codes in the virtual memory from being attacked by other users running the programs in the same virtual memories during execution. By assigning tag keys exclusively to different programs, will prevent information such as the data and the code from being stolen or accessed by malicious hackers. We are now co-working with ARM on their future confidential computing architecture by providing a PUF-based root of trust to protect the boot codes and the data in use by providing tag keys. We believe that the future computing architecture is confidential computing, which will become a major application of our PUF technology in high-performance computing. And this concludes my remarks.